Hi friends, very good evening and thank you for joining in. Could you please confirm in the chat window if you're able to hear my voice and see me clearly so that there are no technical glitches. Again, if you're not seeing the chat window, just refresh the page. The chat window will be available on the right side of the screen. So I can see myself. Yeah, I can see myself and hear myself very clearly. Cool. Very good. Very good. Okay, I'll start sharing my screen and we'll discuss a bunch of topics through the rest of the session itself. Okay, thank you folks. Thank you for the confirmation that there are no glitches. That's good to always to know. And hi folks, thank you very much for joining. We'll start the discussion at 7 p.m. sharp. It's 6:56 p.m. So we'll wait for 4 more minutes because the scheduled time is 7. I try to join a few minutes early because that helps me fix any glitches that might happen. So here, this is, I think, an Eliad which is dried. How much of data structures and algorithms knowledge in general programming is required in the first mock interview? Again, dried, I think that's an alias, obviously. So that depends a lot on your background. I think I've mentioned this in the earlier public live sessions also. If you come from a computer science background or if you worked as a software engineer, you can expect questions in standard data structures and algorithms also. You will encounter more of these questions if you are interviewing at product-based startups or most importantly, product-based companies. If you come from a non-computer science background, they might ask you some basic data structures, algorithms, but not too complex stuff. And there is no limit to it because imagine you're a computer science graduate or you're a software engineer with 2 or more years of experience and you go and interview at a top product-based company. They would expect you to know data structures, algorithms, and the hiring bar for especially machine learning engineers. Again, this depends on the role also. For a data analyst, they don't expect you to know a lot of data structures, algorithms. They expect you to be good at SQL. For data scientists, they expect you to know basic inbuilt data structures like dictionaries, tuples, etc. and be able to use it, be able to write some simple recursion code, maybe use memoization as part of a little bit of basic dynamic programming. But if you're interviewing for a machine learning engineer role, there they might expect you to have a lot of software engineering skills. So the hiring bar there will be significantly higher in terms of data structures and algorithms, especially if you come from a CS background and if you're interviewing at a top product based company. I hope that clarifies the question. Okay. Cool. Can anyone switch SDE role to ML engineer and vice versa? Most of the people that we encounter switch from SDE role to ML engineer role. Very few of them go back from an ML engineer to SDE role. So for SDE roles, ML engineer is the most appropriate role because they can take all of the skills of software engineering, software development, object-oriented programming, data structures, algorithms, big data, all of that they know, and they can apply all of the machine learning skills that they've built and become a machine learning engineer. Again, it depends a lot on the team. There are some teams where a machine learning engineer does 50% software engineering work and 50% machine learning work. It depends a lot on the team itself. Within the same company, machine learning engineers could be doing different types of works depending on the team and depending on how big the team is, right? If your team has a lot of data scientists, a lot of software engineers, then machine learning engineer typically works as a bridge between these two. If your team is small, you end up doing everything from data science to machine learning to data analysis to productionization to software engineering, everything you end up doing, right? So it depends on which team you join. A lot of people go from software engineering to machine learning engineer role because fundamentally, they have a new skill, right, which is machine learning and data science. So they try to build on top of their software engineering skills to move there. Very few, I've not seen any case to the best of my knowledge where people moved from machine learning engineer to software engineering roles. Cool. Okay, very good. Okay. How and what percentage of programming is important to data science? This is Chaitali Mane. I'll cover that in this session. Just give me a couple of minutes. We'll start the session at 7 p.m. sharp. I have a lot of detailed notes, very, very specifics. I promise you we'll spend good amount of time on answering your question. Okay, cool. So this is a question about the next diploma batch. So we are still working with University of Hyderabad. As soon as the next batch is announced or officially announced by University of Hyderabad, we'll make an announcement on this channel. And we are hoping that we'll have the second batch in the second half of this year. So we'll make the official announcement as and when Again, we need to get an official confirmation from University of Hyderabad through their whole academic cycle. Only then we'll be able to announce it publicly. We'll keep you in the loop. Don't worry. Okay. So Ravi asked this question: should I learn Python and then take the AI and machine learning course, or can I take the course directly? Again, if you're talking about the applied AI course that we have, in that course, programming and SQL are part of it, right? So almost our whole first module is just programming, bunch of code walkthroughs and SQL. So we cover Python as part of the course itself, because we know that a lot of students may not know Python programming, may not know any programming in some cases when they aspire to learn machine learning and data science. So we cover it from scratch in our course. Again, if you're taking a course which already covers it, there is no problem. Otherwise, it's always good to learn some programming before you get into machine learning and AI. That's why in our first module itself, we cover all of that. Cool. Okay, Sudhanshu, thank you. I'm happy to see that you're liking some of the GATE lectures that we have. Thank you. So Tanmay says, why product-based companies require a master's degree for ML roles? They don't. So if you go and see the job description, very often they say the minimum qualification is a bachelor's degree or a 4-year equivalent. It is good to have a master's or a PhD, because then they know that you have spent more time studying machine learning. Most BTech folks study the basics of computer science or electrical engineering, etc. They may not get ample time to learn machine learning. So at the end of the day, even if you're a master's or a PhD student or a bachelor's degree student, once you apply, the interview loop will be similar, except that if you have a master's or PhD, the level of interviews could be harder. So there is no, in most companies, in 99% of the companies, for most of the roles, a master's or a PhD is not mandatory. I mean, they say it's good to have. So if you have it, great. But if you have work experience also for a couple of years, that's pretty good, as long as you have the right machine learning skills. Hey, it's 7:02, so let's get started. Just give me a second. We'll get started with today's session. Let me start sharing the screen. Okay, can everyone see my screen? Can you please confirm it in the chat window? I have the chat window open on my computer, on my phone. So can you please confirm if my screen is visible and if my audio is also clear? Then we can get started with today's actual content itself. Okay, good. So I will look at the chat window again in a few minutes once we cover all of these concepts. So today's live session is how to learn programming for careers in machine learning, AI, and data science. Okay. So again, please understand that we'll spend about 60 minutes, approximately about 60 minutes, to cover the key concepts and key ideas that we wanted to cover in this session. So just give me 60 minutes, approximately 50-60 minutes, and we will cover everything that's there in this notes. You don't have to take notes, because I will provide this whole notes in a PDF format at the end of this session in the description section of this video. Okay, so you don't have to take notes. You'll get all of this links and all. I'll provide everything at the end of this session. First. Second, once we finish all of the, because many questions that you're asking are already part of the notes that we have made. So, right, the last 20 to 30 minutes we will spend on Q&A related to this topic, which is how to learn programming for data science and AI. Okay, cool. Okay, cool. So let's get started. So these are the common questions that we get often asked by many students and people who are planning to learn machine learning, data science, and stuff like that, right? What should I learn? What are the good resources to learn? How deep to learn? Because just becoming a deep expert in Python itself can take a decade, right? If you actually go deep into Python programming language, you can spend 1 decade becoming an expert in Python. So the question that we'll try to answer is how deep to learn, primarily with the objective of career transition. Again, remember that our objective here is career transition. That is our key objective, career transition into machine learning, data science, AI. So we will focus on what you'll encounter in interviews, what skills you will need once you go into a data science role or a machine learning role. Okay. Very, very importantly, how to know if you have actually learned what is supposed to be learned. This is a very big question that students have, because students learn a bunch of stuff and they say, hey, have I learned enough, or do I need to learn anything else? And how do I test if I've learned enough? Right? So we will try to answer all of these questions in this live session. That's the core objective of this live session itself. Okay, so let's get started. So as usual, as most of you know, we use Python extensively in data science, machine learning, AI, etc. Again, earlier, just a few years back, some people were even using this programming language like R. Some people still use SAS and other programming environments or languages. R is a very popular statistical programming language, but slowly and steadily R is losing ground to Python. Fundamentally because R is designed keeping statisticians and researchers in mind, right? So today, Python is by default the most popular language for data science, machine learning, and AI for multiple reasons. It's extremely simple. There are like 10-year-old kids who are taught Python in many schools of India and even abroad. It's also fairly powerful. You can get a lot of stuff done in Python. So don't be fooled by its simplicity. It's quite a powerful language. And equally importantly, it's probably the most widely used language for data science, AI, and machine learning. And there are a ton of libraries that people have built over the last decade or so, which will help you. Again, some of you I think have a small screen issue. Just try to watch this in slightly higher definition, like 1080p or 720p. Things will become much more clearer because all of what I'm writing here is text. Okay, cool. So there are a lot of libraries also that are available in Python that will help building stuff for data science, machine learning much more easier. Okay, so that's why we'll focus mostly on Python itself, not on other languages. While they have a role, like R is used by statisticians and some researchers, Python is more and more becoming the default choice. Okay, so some students ask us, what is the best place to learn Python? I think to the best of my knowledge, I mean, if I have to be completely unbiased, the best tutorials I know of Python are at python.org. This is the official website of the Python programming language and the group of people who maintain it. So let me just show you this. So if you just go here, again, this is very, very nice. This is a Python tutorial, very nice, very simple to follow. It covers all of the basics, right? It covers everything from how to use simple numbers, strings, and lists in Python to if else, for loop. So I would consider everything that's here as the most basic stuff in Python that you need to know first. Again, this is the official Python tutorial for version 3.9.4. Again, I'll provide all these links to you. To the best of my knowledge, this is one of the best tutorials to cover the basic foundations of Python. Of course, there are hundreds of other tutorials also online, including ours. For example, if you go to Applied AI course, we have almost close to some 40 hours of content, either in terms of basic videos about Python or some of our live sessions where we do code walkthroughs, close to 40 hours of content. So you can also watch content from Applied AI course. But again, if you want a publicly available, very, very reliable source, python.org is one of the best sources if you want to learn. Of course, we try to learn a lot on how python.org's tutorials are organized when we designed the whole Applied AI course. Cool. So feel free to use any of these resources. And of course, if you just do a Google search, you'll get hundreds of resources. Okay, cool. Now, in Python 3, again, everybody is slowly moving to Python 3, not Python 2, like Python 3.9 is the current version, if I'm not wrong. Now, what should you learn in Python 3? So let me just give you a brief list of all the key concepts. First, you have to know basics of what is a variable, basic if-else statements, loops. Again, everything that I've underlined here are more important concepts. Okay, so the tutorial that I just pointed you to, the Python tutorial, has all of this, by the way. It has most of these concepts. And if you go to Applied AI course and check out, so if you go to Applied AI course, and check out, I mean, there is a lot of free content available there also. So for example, if you go to fundamentals of programming, there is ton of content on basics of Python. Everything where you see a green eye, that's all free content available. And there are tons of live sessions with a lot of code walkthroughs of interesting stuff here also. So feel free to use all these resources. And all of these are basically the fundamentals, like what is a variable, how to use if else, how to use loops. Nested loops is very, very important. Again, a lot of people don't focus on nested loops, but in the real world, we end up writing a lot of nested loops. A nested loop is, imagine a for loop within a for loop within a for loop. Right? This is called a nested for loops. So you can have a nested while loop and things like that. Similarly, basics of what a function is. A lot of people don't realize it, but recursion is a very, very important concept, especially in interviews. You will end up encountering questions related to recursion in a lot of programming interviews. Similarly, inbuilt data structures like list, dictionary, tuple, set. Obviously, list and dict are two of the most widely used data structures in Python and in data science. So it's good to know these in detail. So everything that I've underlined here are more important. Strings you have to know, because in data science and machine learning, you'll process a lot of text. Similarly, regular expressions, very, very important stuff. So that's why even at Applied AI course, in some of the live sessions that we have, let me just take you there. So we have these code walkthroughs about strings and regular expressions. Feel free to use these freely available public resources, because we have a lot of these code walkthroughs which could help you understand these concepts better. Some of these are covered in this Python tutorial, but not in too much depth, right? They're covered at a very high level, not too much depth. So if you want more resources, we have some of these free videos at Applied AI course which you can use. Cool. So these are basic concepts that you have to know. Please note that everything that I've underlined are more important fundamentally because they are more focused in interviews, and they are stuff that you actually use also once you get into a data science or a machine learning career extensively. Okay, cool. Next, of course, you have to know some basics about what are modules, basics of object-oriented programming. Again, a lot of people get confused and think that they have to know everything about object-oriented design. Remember, object-oriented design is when you're given an open-ended problem and you have to design the whole structure of all the classes, all the objects, all the functionality within the classes. So object-oriented design is often not needed in data science. So imagine if you have a software engineering, if you worked as a software development engineer for 3+ years, right? If you have already done object-oriented design, then you can expect object-oriented design like questions in interviews. But otherwise, this is not the major focus. You have to know basics of object-oriented programming. For example, if you want to know what do I mean by basics, let me show you here. Again, by the way, if you want, you can use some of these code walkthroughs that we have in our Applied AI course, Object-Oriented Programming in Python for AI. So that's also a great place. Another place that you can use here is, there is some, look at this. Yeah. So you have this whole chapter called classes here. If you know how all of this works, I think you're in a good place. Okay. So this is also a very nice resource. And this is a pretty good resource, by the way. And we also have publicly available code walkthroughs about object-oriented programming here. That like literally 4 hours of content publicly available that you can check out. Okay, cool. Equally importantly, you have to know how to handle errors like try catch, right? Exception handling, and how to read errors. That's a very, very important skill that a lot of people don't focus on. I'll just come to that in a while. So these are all basics of Python programming. These are not advanced concepts or anything out of the norm. Very simple concepts. This tutorial that I've pointed to has everything covered. And most of these are freely available on our website also. Please go check it out if you're interested. Cool. Now, to what extent should you learn these concepts? So all these concepts that I've just mentioned here, right? To what extent should you know them? That's a very important question. So a couple of very important things. You have to understand the basic syntax and you have to understand common operations. Okay, for example, let me give you an example here. Suppose you have lists, Python lists, right? What are all the common operations in Python lists that are often used? Again, list itself is a class in Python. There are a lot of functionality of lists, but no one can remember. Remember, no one can remember all the functions and classes in Python unless you have designed the functions and classes yourself. Most people can't. And that's only human, right? Unless you have used it extensively or you have designed it yourself, you will not remember it. Now your question should be, how do I know which operations are common? One simple, very useful strategy is cheat sheets. Just Google search for, if you just Google search for cheat sheet, let's say Python lists. Okay, this is one of the top resources that you'll get. Very nice resource from Code Academy. Look at this. This is a cheat sheet for Python 3 lists. All the commonly used operations on lists are listed here. So you have to know all these basic stuff. Like there are some 10 or so basic operations that are used. If you know this, you're good. Similarly, if you want to know about, let's say, dictionaries. Okay, so there is a link here. This is a cheat sheet of all dictionary operations. Again, nobody will know everything. If you know these cheat sheet based, most widely used or most common operations, you're good. Again, at least this you should know. So a simple trick is, of course, you have to understand the basic syntax. You have to know the common operations. To know what are common operations, just Google search for a cheat sheet. Here is one cheat sheet for Python lists, right? That's it. If you know some of these commonly used operations, you're good. And you will also become very comfortable with these common operations as you write more and more code, right? If you write more and more code, you will surely get to know which operations you're using more and more, right? That's, again, nothing beats practice. On day zero, imagine if somebody gives me a new programming language. For me to get comfortable with the basic syntax will take a while. For me to get comfortable with basic operations, again, I'll have to write a lot of code to become comfortable. Otherwise, I'll forget it in a week. Everybody does. It's only human. So to what extent you should know this? Basic syntax, common operations. Again, cheat sheets are a great strategy to know which are the common operations, or you can write more and more code yourself and discover what are the common operations that you're using often. Cool. Next thing here. To what extent should you know these things? You should be able to read the official documentation very, very well. For example, let me just show you this, right? So, okay, let me just open this. Dict Python. So if you just type dict Python, you will get, again, I always prefer to read from the official documentation. This is python.org. So if you just go here, look at this. There is a data structure, more on lists. These are all the functions that are available on a list. List.append, list.extend, list.insert. You don't have to remember all of these. It's hard to remember everything, but you should be able to read this documentation and understand. Okay, that's very, very important. So the ability to read official documentation for any of these basic functionality is super. I'll write it as one of the most important skills. Okay. Similarly, you should be able to read error messages. When you're writing your code, when you're a beginner in Python, you will have a lot of syntax errors, or you might even have logical errors where you have not written the logic behind the code correctly. You should be able to read the error messages, and you'll be able to read the error messages with some practice. This requires practice, trust me. Like when I learned Python, or when I learn any new language for the very first time, it takes time to get used to reading the error messages. Thankfully, Python's error messages are very, very easy to read. So you should be able to read the error messages and understand what are the syntactical errors and be able to fix it. Of course, for things like that, things like this, you can always use Stack Overflow and other places, right? But with time, you'll become comfortable at it. These are the fundamental skills that you need in programming for data science. Again, for any engineering, by the way, this is not just for data science. If you want to become a software engineer also, these skills are very, very important. Okay. Now, another question here is, to what extent, again, I'm just continuing on the same thread. So I said nested loops are very important. To what extent should I know nested loops? You should be able to implement basic stuff. For example, if you have a matrix multiplication, right? Let's assume you have two matrices. Can you implement matrix multiplication from scratch just using nested loops? This is one way you can test whether you actually understand nested loops. Reading theory will not help. Trust me, if you just read theory or read some blogs, you will never learn programming. You will learn programming only through practice. There is no replacement to it. And once you practice and learn programming, you can learn any new programming language very quickly. Similarly, simple sorting algorithms, right? See, if you have a simple insertion sort or any sorting algorithm, you can just Google search, read up about these things, and see if you can implement this sorting algorithm using simple nested loops. Again, insertion sort is simply a for loop in a for loop. Very simple code. Now, the key idea here is, can you implement it using nested loops? If you can, then you understand nested loops, or else you just know the theory behind it. You can't write code. That's very, very important. Similarly, when I say you have to know recursion, you not only have to know the concept of recursion, which is a function calling itself directly or indirectly, you should be able to implement recursion itself. For example, in some of our code walkthroughs and freely available videos, we describe how binary search works. It's a very simple stuff. It's nothing rocket science. You can implement binary search very easily using recursion. Similarly, you can implement, let's say, a power b. Suppose you have this function a power b that you want to implement. This is available in math, by the way. So there is a module called math. So math.pow. I think this is, again, I don't remember the syntax behind it. Let me just check it. Math.pow in Python. Again, whenever I forget something, 1 second, sorry, let me just math.pow. Okay, give me a second. I think my mouse is missed. Okay, math.pow, Python. It's there in most programming languages. Okay, so it's better to go to the official documentation. I always prefer that as, okay. So math, so this is the math, this is the module which does math.pow. Okay, so POW, yeah. So math.pow is this function, which is x raised to the power y. can you implement this from scratch yourself using Recursion? This is an actual interview question at a product-based startup. This is an actual interview question, by the way. Even in some top product-based companies, this is often asked as a starter question. Right? It's not rocket science. It's very simple. This is there in the math module. So can you implement this simple stuff? Again, if you want to see more such examples, you can just go to Applied AI course, look at the live sessions in module 1. We have a lot of these code walkthroughs. Where we touch upon this point specifically. So feel free to check that. Cool. So next, okay. So similarly, to what extent should you know regular expressions? So in machine learning, data science, we process a lot of text. So can you write a regular expression for a phone number in India? Can you write a regular expression for a phone number in the US? Can you write a regular expression for phone numbers with international ISD code? Can you write a regular expression for emails? Can you write a regular expression for zip codes in the US or pin codes in India? Right? Again, we have some code walkthroughs for these also publicly available. Please check it, where we saw a lot of interesting problems here. Similarly, to what extent should you know object-oriented programming? Again, remember, object-oriented programming, you have to know the core concepts, including multiple inheritance and all of this stuff. But object-oriented programming will help you most when you read the documentation. Suppose if you pick a new library like NumPy or Scipy or any of these libraries, most of them are implemented using object-oriented programming. Similarly, when you have errors, if you want to read these errors, you have to understand the basic terminology and concepts of object-oriented programming. So object-oriented programming, very often, data science folks are the users of object-oriented programming. They use it. They don't design it as much. Very rarely do they design it. Again, it's software engineers who do that extensively, right? So the concepts of object-oriented programming are extremely useful in reading the official documentations and understanding it of any new library that you come across. Sometimes you might have to extend the functionality, right? Suppose imagine for a NumPy ND array, which is, again, NumPy is a very, very popular numerical Python library, right? So suppose there is some functionality already there and you want to extend it slightly. You can just do simple inheritance of a class and then extend the functionality. Nothing rocket science there. So you don't have to be an expert in object-oriented programming in most of the cases. Cool. So again, please understand that what is important is just not knowing the concept, but also applying the concept to solving some of these simple problems. Again, if you go to any of the popular coding platforms, right? If you go to Geeks for Geeks, right? Or better still, LeetCode, right? You can encounter tons of problems which are simple nested loops, tons of problems which are simple recursion, or tons of problems which are simple regex problems. So please try to practice coding, because in the interview or even after you join, you have to actually implement this. Just knowing the theory is not sufficient for most companies. Okay, so and you'll become good at it only through practice. There is no escaping that fact. That's why in our course we have so many assignments, because assignments are a way through which students practice actual Python programming and become good at it by the end of it. Okay, cool. So next thing is, what about libraries? There are a lot of libraries. There are literally hundreds of very important libraries. I'm only covering the most important ones in data science and machine learning. Again, this is not the exhaustive list. This is the most popular ones. For example, you have NumPy and Scipy, right? NumPy is for numerical operations. This is for scientific operations. Very simple. The logic is the same. If you just Google search for NumPy common operations or NumPy cheat sheet, this is from datacamp.org. If you just click on this, this is a cheat sheet for NumPy basics. Look at this. It talks about ND arrays, all the common operations that you typically do. It's good if you know all of these basic operations. These are not rocket science. These are like, most of these are used, most of the code that you write using NumPy, 90% of it will use mostly these operations only. So you have to know these basic operations for sure. Similarly, again, this is the cheat sheet for Scipy linear algebra. Again, Scipy is a very, very big library because it's used by all sorts of scientists, not just machine learning guys, right? So it's used by a lot of people. So this is cheat sheet for Scipy with respect to linear algebra, which is what we use extensively in machine learning and data science. So again, here is a list of common operations, eigenvalues, eigenvectors, singular value decomposition, common stuff. If you know this, I think you are in a pretty good shape. Okay. Again, you will get comfortable with these most commonly used functions only with practice. If you just read it today, tomorrow you'll forget it. Even I will forget it, no? It's only human. Okay, it's only by using this functionality day in and day out that you become good at it. So whatever is there in these cheat sheets, whatever is the functionality that's there in the cheat sheet, if you understand those classes and functions in NumPy and Scipy, you're in a pretty good shape. Very, very importantly, you should have the ability to read documentation and understand, especially NumPy, Scipy. It will take a while to get used to it. For example, if I just type Scipy integration, you can do integration. Come on. Scipy integration. Okay. So there is integration function to, because we do a lot of integration and differentiation in machine learning, right? So there is actually a scipy.integrate. There is a whole sub package with all of these functionality. The good thing with NumPy and Scipy, and the reason they've become so popular, is because they have terrific, really, really brilliant documentation. Brilliant documentation. Look at this. They give examples. They tell you how to do it. They tell you pros and cons of each of this. For example, if you want to see, let's say this quad, okay, how does it work? There is a very detailed function. Every parameter is explained, and you have to be able to understand it. You don't have to remember all of this. Like, I don't remember the function. I don't remember this function by itself. If I have to implement some integration using Scipy, I Google search. All of us do, right? Unless I've written it 100 times, I don't remember it. I'm very bad at remembering personally. This happens to all of our mentors also, right? But we are pretty good with some practice over the years. We become very good at reading this functionality, reading this documentation and understanding. And the best part about Scipy NumPy is it has tons of these examples, which is great for us. Okay. So you should be able to read the documentation and understand these classes and functions very well. Even the functions which are not commonly used. Okay, cool. There is one more aspect that I wanted to touch upon. This is extremely important and often overlooked. Okay, let me tell you that. This is an often overlooked part of learning programming, especially for data science. The question here is, this is how you can test whether you have understood the concepts and whether you're good at programming. Can you implement some common functions from scratch? Like, for example, in NumPy, I'll just give you some examples. In NumPy, there is a numpy.concatenate. Imagine if this function was not available. Can you implement np.concatenate from scratch? Can you implement hsplit or vsplit or reshape of a NumPy ND array? Can you implement the dot product in NumPy? Can you implement the matrix product in NumPy? Can you implement these common functions from scratch? Again, as you go towards top product based companies, you will encounter more and more questions like this. Again, these questions are very, very popular interview questions, fundamentally because they test two things. An interviewer can assess by just asking one question like this. The interviewer can assess, can you program? And do you understand the internals of stuff? Do you know how, let's say they ask you about matrix product or reshaping or concatenate. Do you understand how things work internally? Even at least a little bit. You don't have to write the most optimal code, but do you understand how things work internally? Right? So it's a very, very common type of question that you'll encounter, especially at top product based companies. Again, very often, lot of top universities like Stanford, IITs, all of the top universities in their coursework, they often ask you to implement some of these functions from scratch. Right? So if you see the deep learning course at Stanford, they ask you to implement backpropagation, which is a very, very popular algorithm in deep learning from scratch without using any libraries. Because that will help you understand how this algorithm works internally, and it also improves your programming skill. We have something very similar to this in our assignments also, where we ask our students to implement backpropagation for a simple network from scratch. It is extremely important and often overlooked skill. Okay. Similarly, if you're talking about plotting, there are again tons of libraries to do plotting in data science and machine learning. The most popular plotting libraries are Matplotlib, Plotly, Seaborn. There are tons of them. For any library that you're picking up, there are three questions that you should ask yourself. What are the common operations that I should be comfortable with? How do you get common operations? Just Google search for cheat sheet. If you just Google search for cheat sheet in Matplotlib, you'll get some very good take the top results. Get comfortable with the common operations that are there in the cheat sheet. And again, if you write more and more Matplotlib code, you will anyway get comfortable with most of the operations that you have in the cheat sheet. The cheat sheets are designed by people who have written tons of Matplotlib code, and they've compiled the list of most commonly used functions and classes. Very important. The second, so this is one of the important stuff. The second thing here is, can you implement some of the functions that are available in this from scratch? For example, in Matplotlib and Seaborn and Plotly like libraries, you have automatic functionality to plot a histogram. Now, if I tell you, please don't use this function, can you plot a histogram from scratch, given some data? Similarly, can you plot the PDF of the probability density function of a random variable given some data? Can you plot the empirical PDF from scratch without using the plot function that is inbuilt in Seaborn or Matplotlib to directly plot the PDF? Can you plot the CDF function from scratch? Again, we have some of these as assignments in our course, and students ask us, hey, why don't I just use what is there in Seaborn? The reason we are asking this specifically is because this single interview type of question can help you assess, do you understand the concept of a density function? Do you understand the concept of a CDF? Do you understand the concept of a histogram? If you understand this concept and if you're comfortable with programming, you should be able to implement it from scratch very easily. Right? Similarly, the third very important thing is you should be able to read the documentation for these libraries and understand. The good thing in data science is the most popular libraries have the best documentation. Again, if you ever design a library of your own, make sure you have great documentation, because if you don't have good documentation, your library will most likely fail. Right? So this is very, very important to have, to know the basic, I mean, for example, let's look at Matplotlib, right? I mean, it's one of the best. Matplotlib, let's say PDF. Okay, so Matplotlib, not PDF. Oh, PDF, it's thinking, okay, density. It's thinking PDF as in the document format. Okay, this is towards data science. This is a blog. Density function documentation. Okay, see, pyplot.hist. So this function plots the histogram. Given some data, it will plot the histogram for you. Right? Again, I don't remember this function by heart, but it's so easy to read the documentation and get it to work. So easy. And the best part about this here is there is tons of sample code here. Look at this. If you just go here, it will give you some sample code on how to plot it. The best libraries have the cleanest documentation. Look at this. Every parameter is very, very clearly explained. And there is tons of sample code for you to get started. Okay, sorry. So where are we? We are here, right? So the best libraries anyway have great documentation and a lot of examples. If you can understand it, you're good. Cool. Similarly, data wrangling, which is basically how do you get data or load data and process the data. Oftentimes in machine learning and data science, Pandas is the default choice. But you have to know basic file handling in Python, how to read a file, write a file using inbuilt functionality of Python. But more and more Pandas is what is used. Again, here also the same three things. What are the common operations? Are you comfortable with the common operations? How do you know what are the common operations? Cheat sheets. Can you implement some of these from scratch? For example, in Pandas, if you have data frames, you have to merge these data frames, or there is a group by. Right? Very, very commonly used functionality in Pandas data frames. Can you implement a merge or a group by from scratch using simple loops, using recursion, using inbuilt data structures? Right? Again, this is a great way. I mean, I cannot emphasize this enough. Like, it's very, very important. One thing that when I learn a new library, the way I assess myself that I understood this library reasonably well is, can I implement some of these functionality from scratch? If I have an answer to be yes for most of the functions, I know I've understood it fairly well. Again, third thing, you should be able to read the documentation and understand. These are the three things any library that you're picking up, whether it's Pandas, whether it's NumPy, Scipy, whatever, even scikit-learn, whether it's TensorFlow, can you answer these three questions? Is the answer, do you know the common operations? Yes. Can you implement some of these from scratch, or most of these from scratch? Should be yes. Can you read the documentation and understand? Yes. This shows that you understood that library reasonably well, that you can actually claim that you know that library fairly well. Not an expert, but know very well. Another very important but often overlooked aspect of Python programming for data science is numerical programming. So if you go to Applied AI course, we have tons of live sessions. So we have some code walkthroughs on numerical algorithms, right? So again, anything with an I symbol, it's publicly available. We have a live session on how to fix bugs, how to debug, right? How to read error messages and things like that. Feel free to use all of these resources that are publicly available. And This is very, very important because at the end of the day, most of data science, machine learning, and AI is numerical programming. It's just applied numerical programming, right? So you should be able to implement these common operations that you encounter in the math module, right? So I just showed you math.pow, right, which implements x.y. Can you implement, again, you don't have to implement all of them. Can you implement some of them from scratch yourself? Can you implement some common functionality in NumPy, Scipy, Matplotlib that you use in data science from scratch? For example, imagine I have an integration. Suppose I want to integrate this function fx dx from a to b. Can you implement this in Python? Okay, without using the inbuilt functionality that's there in Scipy. Can you do that? Okay, that's again, these are very often asked interview questions in some of the top product-based companies, also top product-based startups. Because in a single question, I understand whether you know the concept of integration, whether you can write code, right? So again, can you compute the derivative of a function at some x equals to x0? Can you plot the empirical CDF? Again, for many of these examples that I'm giving here, we have videos, freely available videos in the numerical algorithms that you can check out. Okay, so again, numerical programming is very, very important and very, very fundamental, because if you take any of data science, right, at the end of the day, most modern machine learning and deep learning is applying some stochastic gradient descent or variation, right? And what is a stochastic gradient descent or a variation of it? It's just a numerical algorithm with some loops. That's all, right? So if you know how to implement it, I've seen a lot of people who say, hey, I know so-and-so library. But when I ask them, okay, you know Scipy, right? Can you tell me, we use a lot of derivatives in machine learning. Can you tell me how we can implement something like that? I'm not looking for the optimal implementation. Give me some sensible implementation. Okay, there are many ways to implement it, by the way. Can you give me at least one sensible one? That's very, very important to be good at data science and machine learning. Similarly, numerical programming, there are tons of concepts, right? So in statistics and probability theory, there is something called KL divergence, which is used to measure how different or how similar are two probability distributions. Can you implement a metric like this? Right? Can you implement a metric like, can you write a function which takes some data and returns me the 99th percentile value? Right? Very simple question, nothing rocket science here, very simple question. Similarly, can you take a mathematical function and tell me the maxima and minima of the function? Again, this is nothing but applying stochastic gradient descent and trying to find minima and maxima. That's it. That's all it is. In statistics, there is a concept called proportional sampling. Can you implement proportional sampling from scratch? Can you write code to compute permutations and combinations? Can you find the distance between a point and a plane? Because this is often done extensively in linear algebra related to machine learning and data science. Very simple stuff, right? Again, for many of these, we have code samples in our code walkthrough live sessions. Please check them out. These are very, very common stuff. The better you become at numerical programming, the better you will have a grasp of the fundamental mathematics behind data science. Okay, cool. Now, there are other concepts which you also need to know in Python, especially for data science and machine learning. For example, APIs is a very important concept. For example, you have to know how to use an API. Imagine you have an API available from Google, Microsoft, Amazon, how to use that API in Python. That's very, very helpful. Similarly, how to build an API from scratch, because this will help you in productionizing your models. You can use tons of alternatives. There is Fast API, there is Flask API. You can build APIs in Django, all of that stuff. It doesn't matter. You should at least know one of these ways in which you can deploy your machine learning model and make it available through an API. Very, very useful, especially with respect to the engineering aspects of machine learning. Cool. Especially if you come from a computer science background, or if you have worked as a software engineer, it's good to know about multiprocessing and multi-threading, where you're using multiple processors, or if you have a hyper-threaded CPU, how to run multiple threads. Again, if you want to know more about multiprocessing, multi-threading, here is official documentation. And oftentimes people don't ask you theory questions. People might say, hey, how can you implement matrix multiplication using multiprocessing or multi-threading? How can you implement a parallel matrix multiplier? Suppose you're given a matrix A and you want to multiply with matrix B. Suppose this is n cross m and this is m cross k, two matrices. How do you multiply them? Of course, you can multiply them using just one simple thread, but how do you implement it using multiprocessing and multi-threading? Again, these questions are more popular if you come from a CS background or if you have worked as a software development engineer. But it's good to know these concepts. These are slightly advanced concepts, but nonetheless very, very helpful, especially in data science and machine learning, where we are doing a lot of mathematical operations, a lot of data operations. And many libraries use multiprocessing and multithreading internally, right? Like NumPy uses it, scikit-learn uses it, TensorFlow uses it, all of them use it. So it's good to know how they work internally. Okay, cool. Now you have to also have a basic understanding of space and time complexity. If you're a CS student, you have to know more. But even if you're a non-CS student, you have to know how to, like, simple question. Given a simple nested for loop, can you tell me what is the time and space complexity? Given simple recursion, can you tell me what is the space and time complexity? Similarly, for any code that you write, can you tell me what is the space and time complexity of that? Again, here the bar is not the same as a software engineer. But you have to be able to assess, you have to say, hey, this algorithm is better and this algorithm is not better based on space and time complexity. Similarly, can you use simple data structures like dictionaries to reduce the time complexity? Right? Again, there are tons of these problems on LeetCode like platforms that you can practice from. Right? So again, as you go to a higher company, by which I mean, as you go to a top product-based company, the questions will become harder and harder. So some of you might say, what about SQL? So we have another earlier live session where we discuss about what to learn in SQL and to what depth you should learn SQL itself. Again, to put it briefly, in SQL you have to be very, very good with nested joins and nested queries basically, right? 3 nested, 2 nested type of queries. Again, we have a detailed live session that we did a few months back on what to focus on SQL with a lot of sample questions also. Okay, I'll provide this link and you can check it out on our channel. It's publicly available. Okay. So that's all I had as far as my content is concerned. It's already 7:40, so 45 minutes. So let me just go and answer as many questions from you as possible. Okay. So let me just go to the chat window. Cool. So Arpan has a question, very nice question, which is what all data structures and algorithms should we know? So let me answer that question. So we'll probably do another full detailed session on data structures algorithms itself, probably in the coming weeks. But if you come from a CS again, this depends a lot. This question is very much dependent on what your background is. If you come from a CS background, and if you come from a CS background, or if you've worked as a software engineer, you have to know everything that you study in your undergraduate level data structures algorithms. If you come from a non-CS background, you have to at least know basic stuff. Like, for example, you should be able to use divide and conquer through recursion. Right? You should be able to use inbuilt data structures like dictionaries, lists, sets, tuples, etc. Right? You have to know basics of space and time complexity. Again, we'll do a detailed session on that. But as a simple rule of thumb, if you're a computer science student, or if you're a software engineer, if you're interviewing for the top product-based companies, you have to know everything that's there in your undergraduate level computer science. If you're not a computer science student, then basic stuff should be good enough. So Samir has a very nice question. Samir, it's a very apt question also. So what if you're interviewing at an IT services company like Accenture, Capgemini, Infosys, TCS, etc.? For them, the level of questions is easier. For example, they might ask you, like, okay, imagine if I give you a data frame. Can you write simple stuff to concatenate the data frame, modify it, all of that stuff? Their questions tend to be on the easier problem solving skills than top product based companies. But you still have to know the basics of the most commonly used functions in NumPy, Scipy, etc. Many of these companies either have a screening test or they give you a task and they ask you to solve it and come to the interview. They shortlist the top performers in that task. To solve that task, you have to know the basic functionality yourself, right? So knowing basic NumPy, Scipy, the most commonly used functions, basic stuff. You don't have to go into the top, you don't have to go into harder problems. Simple. To put it simply, if you can solve easy questions on LeetCode, you're more than prepared for most IT services companies for data science roles. That's a simple rule of thumb that you can use. Okay. So again, this is a question which is about, do CS people need to learn data structures and algorithms for interviews? If you're interviewing at a top product-based company, the answer is yes. If you're preparing for product-based startups, some of them don't ask, some of them do ask. So you should reach out to the HR before you schedule the interviews and know that. For IT services companies, not much. Very basic stuff, basic recursion, basic nested loops, basic SQL. You don't have to do it. Even product-based startups, 80% of them don't ask. The top product-based startups, like if you take your Ola, if you take your let's say Oyo, right? Some of the good top product-based startups, they do ask data structures and algorithms. Others don't. 80% of them don't ask. They focus more on your data science and machine learning skills, less on data structures algorithms. That's why if you're preparing for the top of the top product-based startups, top product-based companies, then data structures algorithms is mandatory for CS people. For others, not so much. Even for CS people, if you're looking for product-based startups, not the top 1%, top 2%, but the others, and IT services, you don't need that as much. Cool. Is DBMS required for data science? So by DBMS, again, DBMS is a big subject, right? The most widely used part of databases for data science is SQL. You will use it every day. Very seldom, very few times you will actually design the data story yourself, because there is a database admin to do that, right? So if you're talking about normalization, all of those concepts, not so much. Like I've not seen people ask concepts about normalization or relational algebra so much. But SQL, yes. And the level of SQL questions also increase as you go towards the top product-based companies. Okay, the hierarchy is very simple. You have the services companies, good roles within the services companies like TCS, Digital, etc., where they ask slightly harder questions. And then you have your product-based startups, the top product-based startups, the top product-based companies. That's how the hardness keeps increasing. Okay. Cool. Again, Sachin asks, should we learn data structures like stack, queue, trees? If you come from a CS background and if you're interviewing at the top product-based companies, like product-based startups or top product-based companies, you should know them. Otherwise, you don't have to worry too much about it. So Ravinder says, what is the contribution of mathematics in data science? If it's high, which topic should we focus on? So Ravinder, you can go to our YouTube channel. We have a video on what are the important topics for a data analyst. Again, the math guys say the data science is just applied mathematics plus programming, and which is true, right? So to have a good career in data science in the long run, you have to be comfortable with programming and you have to be very comfortable with math. There is no escaping that fact. And the number of concepts, fundamentally speaking, you have to be good at, you have to understand the applied aspects of linear algebra, probability, statistics, optimization. In optimization, you have calculus mostly, right? These are the three fundamental areas on which most modern machine learning and deep learning sit on. Okay. Cool. Again, some of you are asking, what about maths for data science and machine learning? You can just go to Applied AI course, look at the course syllabus that we have at Applied AI course. So if you just go through that, you will know what all concepts you need to know. Just go through the topics. Just go through each of the topics. You will get a very, very good picture of all the mathematics that you need to know for careers in data science machine learning. That's, I think, one of the easiest ways, because we've compiled everything there in just one page. If you just go and view the course, Applied AI course, you get the detailed syllabus of each concept. Okay. So is reinforcement learning important for machine learning jobs? Currently in India, even in the US, it's mostly a research area. Very, very few roles ask for reinforcement learning. We have not encountered many companies in India or in the US which ask for reinforcement learning. Most of them expect you to know machine learning and deep learning and basic data analysis well. Not so much of reinforcement learning, and that's why we have not focused it in our course also. We have some basics of reinforcement learning, but not too much, because interviewers don't ask that, because there aren't many, again, where is reinforcement learning used most? It's used in designing games. It's used in robotics. We don't have so many robotics companies in the world. Similarly, we don't have a lot of game design companies in the world, right? That's why it's seldom asked. Cool. I think I've answered this question, right, about databases. SQL is what you need in 99% of the cases. So Rafi says, to go into an R&D role, do I need to have an MTech degree? Again, depends on which R&D role you're looking for. Most are research roles, like a research scientist type of roles, They expect you to have a PhD, or they expect you to have a lot of track record of publishing cutting edge research papers in companies, in journals and conferences. But you can be an applied researcher in the sense that you take the cutting edge and you apply it to real world problems. For that, you don't require a master's or a PhD. Okay, so this is by Shambhu, which is, what about compensation after switching to data science role if a previous experience doesn't add much value? Shambhu, it's very rare that you completely ditch your previous experience, right? Companies, like even if you've worked in testing or development or any of that, right? Some of the skills that you've learned there will surely translate into data science. And even for people with a lot of experience, 5 years, 8 years, even 10 years experience, we have seen candidates get a significant raise when they transition from a software engineer or a testing role or a QA role to a data science role. So that's something that you don't have to worry too much. So this is Vishaka, who says, I'm an electrical engineer. How much opportunity I'll get into AI? Again, what AI requires, there is an advantage for CS and non-CS people. The biggest advantage for CS people is the knowledge of programming. The biggest advantage for non-CS people is their mathematics. As an electrical engineer or a communications engineer or a mechanical or a civil engineer, you guys know much more vector calculus. You guys know much more linear algebra, much more differential equations and concepts like that. You know much more of that than a CS guy. So if you're an electrical engineer, you have an advantage, unlike a CS guy who may have forgotten all of calculus. Similarly, if you're an electronics and communications engineering student or electrical engineering, you probably learned signal processing or image processing or information theory, very important subjects, because a lot of concepts in machine learning borrow ideas like entropy, like information gain, all of that stuff to solve real world problems, right? So, and similarly, as an electrical electronics engineer, you know far more probability than a CS guy. CS guy probably learned it in their second year and forgotten all of it by their final year, but you guys use it more regularly. So the non-CS people's biggest advantage is the math. The CS guys' biggest advantage is programming. So if the non-CS guys can get comfortable with the applied aspects of mathematics and learn programming, it's fairly easy for them to transition to careers in data science. So very nice question. This is by Pranshal Jain. How much programming knowledge is required for managers? Very nice question. So again, it depends on the company. At some companies, managers do code reviews, right? For that, you need to know programming fairly well. Like even as a manager, I used to do code reviews. I used to do model design reviews. I used to go through the design documents and things like that. In some companies, managers don't do so much of code reviews and not so much of engineering hands-on stuff. For them, they don't have to know programming very well. But if you're a manager who is technically very active, you do code reviews, you mentor people under you, then you have to know programming yourself comfortably well, right? So Manish says, will IITs conduct interviews for MTech admissions with all the COVID second wave? We actually don't know. Like a lot of IITs, IAC, etc. are like terrified and petrified with the second wave, because so many students living in close proximity, they all have to go to the mess for their food where they have to take off the mask. There is so much risk there. So we don't know whether they'll actually conduct, we don't know that, to be honest with you. Cool. Domain knowledge in data science, what career opportunities are available? Again, Gridhar, it all depends on what domain knowledge you have. Suppose imagine if you have domain knowledge in banking and financial services. There are a lot of IT services companies that are setting up data science teams. And actually there are banks that are setting up financial services. They're like HDFC is setting up a full-fledged data science and machine learning team to build some of the technology in-house. Like Morgan Stanley, all of these top financial institutions, like Wells Fargo, right? We have an office very close here, very close to our office in Hyderabad. They have their own data science team in India. So if you have domain expertise in financial services and banking, you can always transition to some of these banks and financial institutions, even fintech companies. Right? There is a huge abundance of fintech companies in India, fintech startups, right? All of them are fair game for you. You can take all of your financial services and banking experience and look for these companies. Same with pharma. Imagine if you have IT services experience in pharma companies are starting their own data science teams, number one. Number two is a lot of IT services companies are setting up data science teams to help the pharma companies. Right? A lot of IT services companies are setting up vertical specific data science teams to cater to their needs. So again, remember, you cannot write off domain knowledge. It's very, very important. Oftentimes it is domain knowledge and clean data, and those are what really matter in the real world of data science. A lot of people think it's fancy machine learning, fancy algorithms. While they are important, it's often overlooked about simple data analysis, the power of clean, neat data, the feedback from domain experts. That's super duper important. Cool. So Ganesh says, are there internships in data science and data analytics for non-CS background? Yes. So internships are more widely available in startups. So if you have a career gap and if you come from a non-CS background, try to have a strong portfolio of projects, try to become comfortable in these concepts and apply left and right. You'll get calls. If your portfolio of projects is good, you will surely get, again, the number of calls might be fewer, like the ratio could be 3-4%. Right? We see that from our students who have career gaps, who are applying for internship roles, or some companies might say, hey, we don't want people with career gaps. So there will be all of those back and forth. But if you have good portfolio of projects, good skills, you can get into internship roles even with a career gap. Cool. So Abhijit says, I'm looking for a data science roles in marketing and finance. Is it possible after MBA? Again, MBA guys typically come from a slightly different angle into data science. So again, there are data scientists with an MBA background, but they come primarily from like a domain expert perspective. So the MBA folks who get into data science are domain experts who have a lot of good mathematical rigor and they know data science. So some universities also offer MBA in data analytics and business analytics, right? So if you have the skills and if you have the domain expertise in finance, there are some, not all companies, but there are some companies which hire those type of people also, fundamentally because they have deep domain knowledge and they have the functional skills for a data science. Venkatesh has a very nice question. So after diploma completion, will placement team be able to help in applied scientist roles at product-based companies? Yes, why not? So recently we had at Applied AI course, we had a very nice company. It's called Jupiter.money. Very interesting startup. It's by ex-Razorpay co-founder. The VP of data science there was a very good friend of mine at Amazon. So we conduct, it's considered a top product-based startup. Their compensations are actually slightly more than even Amazon and Microsoft. Their range of compensations is significantly higher than some of the top product-based companies also. So we had them conduct a screening test for everyone. It was open to everyone in our course. They shortlisted about 4 candidates. The screening test was designed by them based on their standards, and they're interviewing them. So we'll do something very similar even for our diploma students or any of our course participants. So we are getting some of these top product-based startups. I mean, their compensation range was fairly high. Because they're so desperate for good candidates that they're willing to even pay 1.5 times what top product-based companies could pay, right? So I cannot go into the exact numbers, but you get a sense of it now. Okay, cool. Okay, so Prasad has this question. Is Applied AI course helpful if I'm going from PL SQL developer to a data scientist role with 5 years experience? Yes, so as a PL SQL developer, I'm sure you know database design, you know databases in general, you also know SQL in lots of detail. So you have some functional skills that are needed for a data science career. So if you can build on top of those skills, if you can learn all of the stuff that you need in data science, machine learning, etc. We have had people who are like DB admins with 5, even 8 years experience who have transitioned to data science careers. So that's very possible. Okay, so Nitesh has this question, which is how to connect applied. Okay, so Nitesh, I think you have like 16 years experience, which is quite a lot. So I would suggest just go to our website, which is Applied AI course. We have our phone number and email address. Please write to us or call us so that we can understand your experience and guide you better. Right? With 16 years of experience, oftentimes for people who have a lot of experience, what we suggest is learn everything in data science, machine learning, start applying it in your current role. Right? Start applying it. Suppose you have 10 plus years experience, right? So you should start to apply everything that you're learning to a module that you're learning, because you're mostly at an architect level or a senior manager level, right? Try to apply that and slowly transition into a machine learning data science career. It will not be like a switch. It will be a slower transition, but you'll have to apply everything that you're learning to newer things. This is especially true for people with 10 plus or even 15 plus years experience. Cool. So Chinmay asks, Chinmay, to answer your question, there are some virtual data science roles. There are some platforms which also conduct interviews and hire from those platforms. They're perfectly legit. So if you go through like YC jobs, they're very good, like Y Combinator jobs, like Angel List, etc. They're very, very solid platforms. Talk to the co-founders of the startup, and their compensations are very good. Some of them actually pay almost the same salary as US or Europe. So, but their hiring bar is also pretty good and pretty high. But if you have the skills, there's nothing that's stopping you from working remotely for some of these very cool Silicon Valley startups or European startups. Cool. Are there any data science opportunities for someone with domain knowledge in aerospace, Karan? To be honest with you, I don't know the answer. Okay, because we have seen very few aerospace companies in India. So I don't know the answer, because there are companies like GE, etc., which hire data scientists for not specifically aerospace. Like, for example, they have a whole wind turbines team where one of my friend works as a principal architect, right? So he's a mechanical engineering structures guy. So they design these wind turbines, right? So they're trying to use data science techniques to be able to better diagnose problems in those things. So in mechanical engineering, companies like ABB, General Electric, all of these top large giants are hiring. Even Tata Motors, Mahindra, all of the automobile giants also are hiring. In aerospace, I actually don't know, to be honest with you. But I'm 90% sure that GE and Boeing doesn't have. I think Boeing has something small in India, nothing big. But I think GE has an aerospace division in India. But we don't know that data a lot, to be honest with you. Okay. Cool. So Asad asks, which person presents insight of data in front of a stakeholder in a company? So it's often data scientists. So one of the very important skills of data scientists is to do the data analysis, come up with the plots which are easy to interpret and understand. So it depends on the company again. Very often it's data scientists or managers of data scientists who present this data to stakeholders. So data scientists, like different companies have different policies. Like at Amazon, we used to have a policy that we have to learn how to write a 6-pager. So anything that we want to present to manager, to like senior management, we had to write it in a 6-pager format. So I went through training to write a 6-pager. There's also something called a 1-pager. Amazon is completely against slideshows, etc. So I went through an internal training. So different companies have different processes. So you learn how to present your work within the format that the company uses internally. But it's often like as a data scientist, I also used to do it. As a manager, I also used to do it. It depends on the company. But data scientists are responsible to some extent in creating the data, providing all the insights to stakeholders, both internal and external. Okay. So how to get a PhD in data science abroad? Is it worth it? So this is by Hegde. So as long as you're going to a good university with a good PhD program in data science, it's perfectly all right. For most PhD students, the admission, you'll have to write your GRE, you need to have a strong SOP, all that standard stuff. like a typical MS program, but needs more commitment. Most PhD students end up getting a stipend, right, or some financial assistance, and it's fairly decent for a graduate level student to survive there. So most universities take care of your finances because you end up working as a research assistant or a teaching assistant. Okay, cool. Sounds good, folks. Again, please understand that as a public live session, it's almost impossible to answer all the questions in live. Anything that I've missed out, feel free to reach out to us. Please go to appliedaicourse.com and email us any questions that you might have. We'll try and answer as best as we can. Okay. Thank you very much. Thank you very much, folks. Bye-bye.